Like, well, does it make sense to go for an advanced course first, or does it make any sense to just get out in the field, get some experience first, and then start working on these more advanced techniques? Hey everybody, welcome to the Profit Dig Construction Show. We're glad you're here with us. I'm Jeff Givens. I'm here with Christopher Work and special guest David Collins. He's an HVAC certification instructor.
Just HVAC instructor. We do certifications too. But
okay, yeah, it's HVAC awesome. Instructor. And then as always, producer Jerry behind the camera. Glad to have you with us as well, Jerry. So we were talking a minute ago, David, about, what these courses look like. Okay, and you were saying it's maybe just a basic introduction. Get the fundamentals through the course.
Right.
Now, if someone wanted to go to the next level, does it make sense to go for an advanced course first, or does it make any sense to just get out in the field, get some experience first, and then start working on these more advanced techniques?
So once they get done, it's just a continuing reading, keeping up with the trends. Every chance I get, there's lots of YouTube channels and books, and there's lots of information out there. Okay. And I try to help them find the places that are trusted that they can go to and to keep that education going.
So are there some pretty good resources out there for, let's call it, continuing education?
Yes. Mm-hmm. Yeah. Several of the big like Train has an education side, and they have lots of online programs that you can get little certificates and certifications by doing by doing them online.
Are those things usually free or paid?
Usually free, yeah.
Really? Okay.
Yeah. And there's others. And then there's some that you have to pay for that get you a little bit better of a certificate.
Mm-hmm. Okay. That's smart too, because this tech, when they're talking to a customer, they're thinking they got trained in the back of their mind when they might be recommending an upgrade.
Yeah, that's right. That's right.
Because they provided all this wealth of information, so
yeah, and it helps them. The employer just wants to know, can you do the job?
Right.
We're here to make money. I'm here to give you a paycheck. Mm-hmm. We're here to get the job done, keep our customers happy.
Yeah.
For the employee, is for you really to better yourself. It feels good when you know more. It makes your daily job easier. Yeah. Every day you go out there, I can't tell you how many times I've been on a job site and I'm like, man, I do not know what's going on here. But then I read something or watch this certain YouTube video about somebody else who's had the similar issue, and they're like, oh, well, it's just a simple little thing, and I'm like, man, well, that's now I know.
It almost sounds like a doctor. It's like who's putting out the white papers, who's doing the research.
Yeah, well, it's kind of like your HVAC residency. When you first get out of school, it's like I'm going to go to work and I'm just going to learn as much as I can, and then see where we go from there. So
you mentioned some trends. Like, what does a trend look like in the HVAC world? Is that new technologies, new regulations? What does that mean?
There is. So basically, the trends from 5 years ago to now are pretty much completely different.
Really? So is this like equipment, hardware type trends?
Everything.
Oh, okay.
Everything.
Okay.
So the government, back when we did the COVID bill, they put in, and I can't remember the exact dollar amount, there's so much money that went toward EPA to change the refrigerants that we're using. So these refrigerants we're using are killing the ozone. So you've got ozone depletion, and then you've got global warming potential, right? So they're coming out with these refrigerants that have zero ozone depletion, but they have a really low global warming potential. And the threshold they're trying to get under is 750.
So what does that mean, a low depletion?
Great question. I want to know.
So back in, I think it was. Is that better? I think it was '87. They signed the Montreal Protocol, and what that did was
that sounds kind of Scary.
Yeah, it was this whole treaty that they signed, and without getting into a bunch of specifics, basically the world coming together and coming up with ways that they can save the ozone layer because they're seeing holes in the ozone, which is where they think
Well, it's pretty important.
Yeah,
The ozone layer.
right.
We need it.
Yeah.
You know,
So,
not a bad
so they're
thing,
seeing these holes and they're wanting to stop. So they did some refrigerant transitions then.
Okay.
And so basically they started phasing out chlorine at that point because they thought chlorine was depleting ozone. Well, as they carry on into different refrigerants, they're getting lower and lower ozone depletion, but the global warming potential is still high. So now what they're seeing is they need to bring global warming down. And I don't understand the ozone layer and the
Yeah.
global warming potential,
Yeah.
maybe that's a whole nother conversation.
Yeah.
Probably, yeah, but
From what I teach, I have to go off of what the scientists say is happening. So, but basically, so as we're progressing, they found refrigerants that are no ozone depletion, so they're not going to put more holes in the ozone.
Okay.
And they're bringing the global warming potential down. So it's just to protect the ozone. Problem is that these refrigerants are flammable, so it kind of changes everything.
so the safety procedures on site,
Right.
probably the way you secure or even transport that material, like everything from a process perspective,
Right.
is
It's going to
impacted.
change. Right. And then and they're
I'm
fast
sorry,
tracking
you
it.
said flammable.
Flammable, yes.
Oh, okay.
Yeah. So for years they've been using R290, which is propane. It's not
Okay.
your grill propane. It is but it's refined a little different. So so like you can't take your propane grill and hook it up to your your air conditioner and it works. It's totally
Yeah.
different. The
Well,
refrigerant
if I do
itself.
that, does that void my warranty?
I believe it does.
How long can I get by
I
with
believe
this,
it does.
actually? I don't think one little propane tank's gonna go too far on a big unit.
Probably not.
Probably not. Yeah.
But so we're transitioning from the refrigerants will burn, but they have this propagation. So there's this 90-degree angle, and so when they put sparks in with the refrigerant, the propagation is how much that fire's going to spread. Well, if you come out of that 90-degree angle with your propagation, and they have measurements.
So we're saying a flame is generated from a pipe. Or from
Right, it's kind of this
from a
kind
break.
of glass sort of beaker looking
So we
thing.
got a beaker. The flame escapes and propagates like this. Okay.
So you
it's
kind of got
coming
your
out.
mushroom kind of flame
Okay.
where it
Okay.
ignites, right? And there's I've seen pictures and stuff of it, and the material I teach out of, I show them pictures and everything. So it's basically this jar, it's got all these lines, and it kind of does like that.
Okay.
So the flame propagation, what happened is you had a A1. Your A is your toxicity level, and then your 1 is flammable, not flammable. So 1, not flammable, 2, mildly flammable, 3, very flammable.
Okay.
So in order for the new refrigerants we got, they had to create a new category, which is A2L. So it's mildly flammable. And that's the refrigerants we're going to start seeing more of, is the A2Ls.
Okay.
So they're friendly to the environment, but they are a little bit flammable. But then everybody hears flammable.
Flammable, yeah.
What
Yeah.
now?
Yeah, you think my unit's a gas unit. There's a pilot light in there. Like, does that,
Right.
if I had a refrigerant leak, is it going to blow the side of my house off? Or is it?
Right. And that's kind of where we're at right now. So in the COVID bill, I forget the official name for it, but they had that big $1 trillion COVID bill. It was like 5,000 pages, I think it was. I don't know if y'all ever read it.
No.
I mean,
I've never read any bill.
I haven't read
They haven't read the bill either.
But
Yeah, nobody has read the bill, but the EPA got some money from the
But
COVID
just seeing
bills.
how many pages it was.
Yeah.
So I kind of scanned a little bit through the EPA section of it. And basically they're fast tracking this transition so they're not saying you can't use this refrigerant anymore. They're saying we're going to this new refrigerant and we're going to phase down Instead of phasing out, we're going to phase it down. We're going to make it less easy to get a hold of.
Okay.
Therefore, it's going to drive the price of it up. It's going to bring your new refrigerant in, and what are you going to, what are you going to choose?
And now,
Yeah.
which Congress people have stocks in this new refrigerant company?
I'm sure that they do.
Yeah, because I want to invest.
We can't talk about that, Jeff.
And along with that,
If I'm not here tomorrow, I'm sorry, guys.
Has anybody heard from Jeff this week?
so along with that, what's happening too is the technology of the equipment itself is changing. So-
Okay, I was gonna say, so you can't put this new gas into my old unit. Okay.
There are some refrigerants that are a drop-in right now.
Or refrigerant.
Your household unit is probably 410A or R22. So right now, there's not a drop-in
Okay.
for those. R22 has been phased out. So you can't just go to the store and buy an R22 unit anymore.
I got you.
But that started to happen in 2008. They started phasing out R22, bringing in 410A. So now that we've got 410A, they're kind of trying to transition that, but it's going to be a little bit different transition
Okay.
because of the flammability factor. So you've got to make sure everything's intrinsically safe.
Sure.
So now, as an HVAC servicing company, I'm guessing just for stock and inventory, we're adding new equipment or new supplies that have to be stored or stocked in their warehouse or in their building.
Right.
So it's as you get, and you can't disregard the older products because you've got a legacy set of equipment out there. I don't know what the longest running HVAC unit is, but
I own one.
you own one of
I
them?
do, yeah. It's like
30
20-something years old.
Really?
Yeah.
Yeah.
But there's probably some extreme examples out there of like 50 years this puppy's been turning, I don't know.
Yeah.
Well, can older equipment be like retrofitted for the new free one, or we're not there yet?
Not for the
I guess.
flammable refrigerants.
Okay.
However, if you have that old piece of equipment, there you just can't get new manufacturing. You can still put a refrigerant in it. It can still be serviced. It can still be worked on.
Gotcha.
You'll be able to keep that. But when, like, say you have a compressor fail, you may not be able to find that compressor.
Yeah.
So that's going to lead you to, okay, you're better off just to change your unit
Just
out.
get a new unit.
Right.
That's
So
what
what's
they've been
happening-
telling me for years, but we'll see.
Yeah.
TVA is coming out with, and again, I don't know all the full details, they're a little hazy. All this is happening so fast that you ask around and say, okay, well, what are we looking at now? Supply houses, and everybody's just kind of like, hey man, we're kind of waiting because everything's in testing right now. Everything is in, they're trying to figure out, okay, which of these refrigerants are we going to go with for our equipment,
Okay.
So some units are going to have an R32, some will have what's called a 454B.
Are those cross compatible, or is that kind of the
They work
direction
at
they
different
think?
pressures, so you
Oh,
have to
okay.
have, everything has to
Gotcha.
be designed
I got you.
for this certain refrigerant.
So that unit will use this specific type of refrigerant.
Right. And so they're still kind of up in the air if we don't even really know, okay, what refrigerant are y'all going to use?
Yeah.
Nobody really knows.
And it's not just like you can swap out a module and
Right.
now it's compatible with the other one.
Right. It has to be so the compressors.
But hey, that's a great idea, HVAC company.
Yeah.
Call me if you want to know more.
Right?
I have zero HVAC experience.
You'll be fine.
Fit right in.
Yeah.
But anyways, the other side of that is, they're wanting to do all this green energy and go all electric, right? So in the middle of that side of things, now they're changing the whole way HVAC unit works. We're making it all electronic. The old unit that you have, I can go out there and throw some old refrigerant in there, get it cooling, and it'll do its thing. Well, this new stuff, so I can go just add a little bit of refrigerant to that one. The way this new stuff is being designed, I could have what I think is the right refrigerant charge and it not be running right because of the type of compressors and motors. Everything is modulating.
Okay.
So, and it changes with load and what it's reading. Outdoor ambient temperature, indoor temperature, humidity. It's taking all these readings and it's kind of electronically altering how those motors Your indoor, outdoor compressors, they're all modulating.
So you're gaining efficiency, but sacrificing maintainability.
Right. You're gaining good efficiency. So
Yeah.
on that end of things,
So there are pros,
efficiency
it's
is
not
awesome.
all cons.
The con is they're extremely expensive to work on. You'll be leaning on a warranty. And the biggest issue we're gonna have, which is great for me, is nobody will know how to work on them. So that's kind of where we're kind of going to have the edge there as far as training. We're kind of training this next generation of guys to come out in the field and be able to work on this stuff. Because you take a guy that's been in the field for 20 years, he's having to go and educate himself on all this.
Yeah.
Because they're hearing flammable refrigerant, and it's like some of the guys are, I'll just throw it in there, let's go. It may work, it may not.
Yeah.
There's been times that I've been that guy. Like, let's see what happens. I mean,
It's like,
it could be fun.
Like, sign here. Yeah, we're gonna do some testing.
I feel like
If you hear a weird noise, I don't know what to tell you.
this laissez-faire attitude may not be good for your health.
That's right.
Yeah. So
That's awesome.
anyways, but yeah, it's all like a mini split system. If you've ever seen a mini split system, they're basically adopting that technology into full size equipment.
And when we say a split system, we're talking about where, I think I have one at my home where we have a condenser unit outside and we have a main unit upstairs.
Right.
Yeah.
That's a split system. So you have that's hooked to ductwork and it feeds the whole house, right? So that's a central unit split system. If you have like a bonus room and you see like that little unit that's just up on the wall, kind of rounded off, just hanging up there, that's a mini split.
A mini split, okay.
And so what they do is they have inverter driven motors. So they're changing the frequency of the electricity to speed motors up or slow them down, depending on what what you need. So instead of a motor running at full speed when it's
All the
running,
time.
if you don't need much, it'll run at a lot slower. You're using way less watts without getting technical into all the electrical.
Yeah, it's a variable speed drive or a variable frequency drive.
Exactly what it is. Yeah.
Okay.
And instead of it, like right now, we've got some of that on blower motors, the indoor that spreads it through the house. But now they're putting it into compressors, into the whole unit. So you take a huge commercial unit that's running this big building, they already have frequency drives in there and they've been doing it for years. Well, they're taking and they're saving a lot of money on that big building without running everything full speed. Well, they're taking that technology, putting it into your home and making it so you've got all that, and then you're going to see more and more they got a VRF system, which is variable refrigerant flow, and this is something you'll see more and more in commercial. And it's kind of the same technology as like what a mini split does, but it's way bigger and a lot more controls, a lot more electronics, a lot more going on. You could have this room heating and that room over there cooling at the same time.
So it's a lot of modular sophistication in the system.
Yeah, it's pretty
Multi-climate capability.
That could be like a 4-day discussion on how all that.
Yeah.
I know we have that at the company I work for. Our office is nearby.
Oh, really?
Yeah, we've got like a breakout room for 8 people, another breakout room for 20 people, a conference room. And each room has their own individual control settings, its own climate. So maybe it's using a similar
It could
technology.
be, and they're kind of, they're trying to, you get into all this green energy stuff, and depending on who you talk to, we could argue and not argue, and all of that stuff, and I don't get into all that, for me, looking at it from a non-political viewpoint, if I can buy something that's going to save me a ton on my electric bill, I'm all for it.
Absolutely.
What
A lot of
else is
tax
happening,
credits and all sorts of opportunity out there.
Yeah. So, but that's the kind of stuff is like they're trying to get rid of like chillers and boilers and these big, they hate natural gas and all this stuff. When I say they, I'm just saying the people who are writing the laws and the bills and getting all this stuff passed through Congress.
That makes sense. I have some natural gas in my stock portfolio, and it is beat up, man.
Yeah.
So I need to just get out of it now. I appreciate the tip.
They are. They're trying very hard. I don't think it'll
Get out while you can.
I might just do it.
This is not a stock recommendation.
It is not. This is not financial advice.
I don't think that getting rid of natural gas, me personally, I don't think getting rid of natural gas would be a good thing. However, there's a lot of people who want it gone, and I'm sure that they're going to try everything they can. But just looking at it just from the basic economic standpoint of how much is this going to cost me daily to run, because we're going to keep this house cool or this building warm or cool, whatever it is. And if I've got a big commercial building and I'm running a boiler that's just burning a lot of gas, and I can turn around and put something like a VRF in that's going to be a lot more economic, run better, more efficiently, and I'm cutting my bill in half, regardless of what I think about the world we live in. I'm going to choose that just to save myself some money.
Well, too, there's almost like a paradigm shift that could happen there too, where if you do, what's the most energy consumptive device you have in your home? For sure, it's going to be your HVAC system.
Yes.
Right?
Yes.
So if you could reduce the consumption of energy on that system and you could do it all electric, you open the door to going off the grid with solar panels or windmills, or wind turbines, or like. So if you're someone who is wanting to take that approach, that kind of non-connected approach, that the more efficient these HVAC units get, the more capable you'll be, because that's the biggest challenge today, is to generate enough electricity to run your heating and air.
Yeah.
Right.
And that's the other, you take like a standard house in our area has a heat pump in it, right? Somebody doesn't have natural gas. They have a heat pump in it. Well, in the winter, you can only go so cold before you have to have this extra heat bank kick in. Well, your wattage being used is your voltage times your amperage. Well, if you take that, a regular unit running in heat pump mode, in heat mode, you're going to be pulling 8-10 amps, something like that total running. Well, and that heat bank kicks in to help keep it up when it's really cold outside.
The emergency heat. Right?
You're adding another 40 amps.
Oh, wow.
onto it. Where with this new inverter technology, you can go a lot colder temperatures without actually needing that supplemental heat. And that's the technology they're really kind of digging into right now and testing. Is getting that technology into bigger equipment. So, and then that brings up the whole geothermal aspect. Then you got geothermal units who have ground loops, and they get all their heat that we need to reject or take in from the ground. Well, if you have that, you don't need that extra heat. Because it's not in that cold atmosphere, it's underground. So that's a whole other thing that I think you'll see. That technology's been around for years.
So we're talking about, you've got a unit buried, and that unit is unaffected by the ambient conditions because it's heavily insulated by the earth, and then you could pump it into your home. Let's say harder to get to, but in terms of it's running, like less problems.
So in short, without getting,
because I don't know anything about it.
Right. And to keep from getting into all the details of it, getting too technical, you've got your split system at your house, right? You've got the condenser that's outside, it's always here running. Well, you can basically take that condenser and it's underground. It's not a condenser anymore, but what it's doing is underground. And then you've got your air handler that's in the house, right? So what's happening is you use water. So that's blowing air across that for a heat transfer. Well, what we're doing, instead of blowing air across it for heat transfer, we're using a water loop. So we're transferring our heat into water.
It sounds like my computer's cooling system.
It's probably very similar. Probably very similar. So those are the kind of things that are going to come up more and more. So a typical unit you put in your house, $8,000-$10,000 to put an HVAC unit in. It's probably more than that right now. It's gone up quite a bit. But a geothermal, you're going to be $25,000-$30,000 putting one of those in. However, long term, they last a lot longer because they're not out in the conditions, and you're going to get a lot more energy efficiency. So, but who wants to spend $30,000 on a HVAC unit?
I do not. I guess I'll just continue to have my unit serviced once every 5 years, and we'll just.
I'm in the boat you're in. I'm just going to keep going.
We'll go over there. Well, man, that's cool stuff, Dave. All right, well, guys, we're on we're going to wrap this one up because my brain is just swelling from all this technological
It's a
advancement in
good
HVAC.
meaty
I know. I'm like,
conversation,
good grief. I don't know. I'm like, do I need to go out and get my unit now? What do I need to do? So I don't know. That might be a topic we hit on.
I just bought a new heat pump earlier this year, and I'm really happy with it so far.
Yeah, that's awesome.
Wasn't happy with the cost, but I'm happy with what I'm getting.
Yeah.
I was spending a fortune on propane.
Oh, propane's so expensive on the heat. Yeah.
So you changed to a heat pump?
Yeah.
Yeah.
And even with that, you take that heat pump versus the propane that you were using, even with that extra 40 amps, you're still way more energy efficient than you were running with that propane.
Oh, I know I am. I was burning through money. I was burning through propane and burning through money at the same time.
At the same time, yeah. There's nothing worse than that.
The money.
Yeah. Shoot. All right. Well, fellas, I appreciate it. David, thank you so much for coming out. Jeff G, producer Jerry, appreciate it as always. Guys, subscribe to the channel, like the video, leave us a comment. We always appreciate you joining us on it. Tell your mom about it. That's right. That's right. Yeah.
I bet she wants to know about it.
I know she does. Yeah, and your uncles and aunties and everybody else. So anyway, thank you for joining us on the Profit Data Construction Show. If you are looking for a job bidding and estimating or costing solution and estimating, you can do it all in there. Check us out, profitdig.com. We'll see you soon.